It's always taking the offsets from the Kate down on the beach there, measuring the hull dimensions. Here we are in my drawing office now, and I'd like to show you how we translate those into a drawing using the traditional methods which have been in use for the last 200 years or so. These are lead weights, and they're called ducks for some reason, although they look more like a whale really, don't they? And we use those, and we use splines, which are flexible battens of, in this case, perspex. They can be timber or anything. We plot a series of points using the offsets we got from the beach down there, and then we have to join these up with a nice smooth curve. Offsets. I'm going to pull that down, just drop that on. You can decide to long it to see how smooth it is, like so. There we are, now let's out a bit there. There's a little bit of hollow in the waterline. This is a waterline that we're drawing here, and then we'll run it in with the pencil. Okay, another technique we use is ship's curves. I have a selection of them here. These are called sweeps and an S-curve here. This is one of my favourites. It's called Dixon Kemp's curve, after a famous yacht designer of the 1880s. So the aft end of this waterline sweeps in quite suddenly to the centre line, so it's too sharp for the batten, so I'll use one of Dixon Kemp's curves here for that. Just take these away. You get to know your curves and you sort of learn which kind of curve you want. I reckon it should be tightest near the middle of the boat there, probably. And we'll just fare it all in from there. Okay, it's going to have to come round in 2 sections, I think. Yeah, I'll do it round to there. It's got a bit tighter inside there. Maybe use that one will do the trick. There we are. And that's going to be our deep loaded waterline after we've got the ballast on, or at least the first go at it. It's a matter of what they call iteration, trial and error, until we get what we want. Of course she'll be lower in the water once the ballast is added, so this is the waterline as she's floating on at present. So the reason we're doing all this is that in order to gain licence for carrying passengers, we need to do plan approval by qualified naval architects. And this involves finding doing drawings of the construction of the boat and calculations to show it's strong enough, in particular the new outside keel that we're putting on, the lead keel, and also stability calculations. I can show you what's involved a little bit with that. This is a naval architecture textbook. The boat, what they require for carrying passengers is positive stability to 110 degrees of heel. That means the boat's laid right over so the mast's in the water. This boat here, this part of the curve means it's positive. At that point it's just balanced, and at that point it would go upside down rather than right side up. And so we need it, there's 90 degrees, we need it to 110 degrees. And so we will plot a stability curve for the Kate. This will all be done on computer once we've inputted the drawing, because the calculations by hand are incredibly tedious to do this.